Rational expressions, yep. Yeah. Adding and subtracting rational expressions. So if I had 1/12 plus 5/12, what does that equal? 6/12, which we can simplify, right? 1/2. Mm-hmm. Yep. If I had 1/2 minus 1/3, can I just do that real quick? No, what do I have to do? I have to get a common denominator. So 1/2 would change to 6. Yeah, because 2 and 3, the common denominator would be 6. So 1/2 would actually be, I'm going to put a little arrow, that would be 3/6 minus 1/3 would be 2/6. And so what would it equal? 1/6. So when we multiply and divide fractions, we don't need a common denominator. With multiplying, you just multiply straight across. With dividing, we have to keep it, change it, flip it, but then we can just multiply straight across. When we add or subtract fractions, we have to have a common denominator. So that means that when we add or subtract rational expressions, we need a common denominator. And that's what makes this day a little bit more difficult. Now, what I've noticed is that students, once I put rational expressions in front of them, they tend to start making mistakes with other things. They'll focus so much on finding the common denominator that once they have it, they make mistakes with the rest of the problem. So what we're going to focus on today is we're going to simplify problems that already have common denominator. Okay? Tomorrow, so tonight's video is going to be on getting a common denominator, and then tomorrow we're going to practice the ones where you have to get a common denominator before you can do something. But today, all the problems are going to have a common denominator to start with. Okay? So we're just going to do a few examples until we feel like we're starting to get it, and then I have some practice problems for you. So our first example is a plus 3b divided by 20b minus a minus 5b divided by 20b. All right, so the first thing I'm going to do is I'm just going to write this as one fraction. So I know that 20b is my common denominator. So for the first part, I do have a plus 3b. And then I have to keep in mind that this is a subtraction problem. And so I'm going to minus the a and minus negative 5b. You could put them in parentheses with a negative and then show the next step is you distributing. You could do that. So minus a, and then what happens when we minus negative 5b? Plus. Okay, so at this point, what happens? The a's cancel, and what do we have? Not negative 2, 8b. 8b over 20b. Because you subtracted it. So the b's cancel. And we have 8 over 20. We can divide out what on both of those? 4. So that's going to be 2 over 5. So 2/5 is our answer. All right, here's the next one. X plus 4y divided by 15x squared y minus x minus 2y divided by 15x squared y. So what do I do first? Write it as one fraction. So 15x squared y. I'm going to keep the stuff from the first fraction, so I'm going to keep the x plus 4y. And then what am I going to have next? Minus x plus 2y. Okay, so what do we have? The x's cancel, and we have 6y, and then 15x squared y, and then what do you guys see? Take out a 3, so divide by 3, you get 2, divide by 3, you get 5. Yeah. Yeah, and then the y's can cancel. Does anyone know why we are not killing puppies right now when we do this? We did it at the end, but also there's no pluses or minuses in the problem. So right now everything is being multiplied together, which is why we can cancel without worrying about it. Okay. All right, so what do we have left over on the top? 2, what do we have on the bottom? 5x squared. Okay. All right, let's do another one. This one is going to be k plus 4 over 5k plus 20 plus 2k plus 11 over 5k plus 20. All right, so what do we do?
K plus 4 plus 2k plus 11.
Okay, so we're putting it as one fraction, right? So we have the common denominator. So we said k plus 4 plus 2k plus 11. So when you're adding rational expressions, it's a little bit easier. Why was it a little bit easier? Yeah, you didn't have a negative to distribute. So what I have noticed is that students will often be okay with adding rational expressions, but they will often make mistakes with subtracting. So when I made your guys' worksheet today, I made every single problem a subtracting problem. just being honest. I was like, they can't get it wrong if it's every single problem. At some point, they got to figure it out. So I took all the addition problems off because, yeah, literally. I called the title adding and subtracting because it seems silly to say, like, we're not going to add today, we're only going to subtract. But really, you're only subtracting. Sorry, not sorry. All right. So what do we have now? 3k plus 15 over 5k plus 20. Okay.
Can we simplify that? I mean, take the GCF out?
Take the GCF out. So yeah, once you're done with the adding, it switches over to being a problem like what we've been learning already. So we can take the GCF out of the top, and what does that leave us with? K plus 5, and then we take the GCF out of the bottom. 5, K plus 4. Dang, I thought that was going to do something, but it didn't. So either of those answers are fine. Those are both good answers. You don't have to take out the GCF only because it didn't cancel. If it had canceled, of course, we'd have to do it. Maybe this one. Sometimes when people look at it and go like, oh, it's not going to cancel, they don't take it out. They just leave it. Yeah. So either of those are good. All right, here's the next one. K plus 1 over 20k minus 12 minus 3k minus 1 over 20k minus 12. So, what do I do?
Make it all one big fraction. K plus 1 minus 3k plus 1.
So minus 3k plus 1.
Then you get negative, wouldn't it be negative 2k plus 2
Okay.
over 20k minus 12? And you're going to take your GCF out of that, which would be negative 2. So that would be k minus 1 over with the 2k minus 1. And then 4, 5k, 3.
So we took a GCF out on the top. We took a GCF out on the bottom. And the GCFs in the front you can reduce. You can't reduce the fraction or the parentheses, right? Because they're not identical. So no reducing those. But we can reduce the numbers in the front. 1 over 2. So negative k minus 1, 2 times 5k minus 3. This answer is totally fine. But if you wanted to distribute the negative back into the problem and distribute the 2 back into the problem, you could. But you could leave it the way it was. So what was the process that we did for these? What did we do first? What did we do after that?
First distribute the sign.
Before that, so yeah, kind of. So first what we did is we took the 2 fractions, we wrote it as 1 fraction, right? So we put the common denominator there, and then we made sure that if it's a negative problem, we distribute the negative, okay? Once it's 1 fraction, what do you have to do at the top? Combine like terms, so you just clean it up a little bit. Make it so it's written as 1 fraction then. And then after you combine like terms, what do you have to do before you say you're done? Yeah, you have to see if you can factor and do some canceling. Okay, so it's kind of, if you guys notice in this unit, each day kind of leads into the next one. Like, we don't go like, oh, what we learned yesterday has no bearing on what we do today. What we learned yesterday affects what we do today, right? Because we're just like doing the same thing repetitively. Okay, so I have some practice problems of that for you guys.